Our study in Chapter 9 begins with looking at the key terms in this chapter on carbon chemistry. As we study the different types of organic compounds, simple organic compounds, and then biological compounds, it's going to be really important as we read through this to first have an understanding of what these terms are before you get into the reading. That way you can attach your new learning to the background knowledge that you already have. So what I'd like to do is go through the terms that are listed here at the top in kind of this word bank, and then work through the different example sentences that you're supposed to fill those in with appropriately. So I have my textbook open in front of me to my glossary, and I'm going to look through the different definitions that I can find of these terms. Once I have an idea of what the definition is, then I can maybe try to apply that definition in the example sentences that are listed here. So if we begin in the H's in the hydroxyl group, I have to turn my page a little bit and search a hydroxyl. It consists of an oxygen atom and a hydrogen atom joined by a covalent bond represented by the formula OH. So a hydroxyl group consists of an oxygen atom and a hydrogen atom joined by a covalent bond. Important to know. Next I have amino acids. Turn my page in the glossary to the amino acids, or letter A. When you find amino acids on page 714 says building blocks of proteins contain both an amino group and a carboxylic acid group replacing hydrogens on the same carbon atom. An amino acid, the building blocks of proteins. Important to remember. Next we have saturated. I've got to turn my page all the way to the S's to find the term saturated, as it's talking about this carbon chemistry. Saturated describes a solution that holds the total amount of a solute that it can hold under given conditions. A saturated hydrocarbon, for example, is a hydrocarbon such as methane with only single bonds. So there's two definitions for saturated. We learned about saturated solutions in our previous study. Now we're applying that to our study of hydrocarbons and carbon chemistry. Top of the page here I have organic compounds. The word organic is what we need to focus on here, and in our glossary it says most compounds that contain carbon. Organic compounds are most compounds that contain carbon. Interesting. Next is lipids. I find my L's here in the glossary. A lipid is described as an organic compound that contains the same elements as carbohydrates but in different proportions. Well, we should probably look up carbohydrates because we want to put those two things together. So I'm going to jump to carbohydrates quick so I can recognize what those items are that are in carbohydrates. Carbohydrates are organic compounds containing only carbon, hydrogen, and oxygen, starches, cellulose, and glucose, and sugars. Okay, so a lipid is the same thing in terms of carbon, hydrogen, and oxygen, but in different proportions. So carbohydrates and lipids are similar to each other. Just a little quick hint, lipids are also known as fats. So if you eat food or you see food that says low fat, that means they're trying to get rid of the lipids inside of that. Unsaturated. We know what saturated means. It means it has all of what it contains, or it has all single bonds when it's talking about the bonds that are between different types of molecules. An unsaturated hydrocarbon then must be something different. In fact, an unsaturated hydrocarbon is a hydrocarbon such as ethylene with one or more double or triple bonds. So unsaturated means it's got double or triple bonds rather than saturated compounds which have all single bonds. A carboxyl group, because we already did carbohydrates, a carboxyl group is identified as consisting of one carbon atom and two oxygen atoms and one hydrogen atom, represented by the formula COOH. Next is isomers. If I'm looking at my definitions, I have to change to letter I. An isomer is a compound with the same chemical formula but different structures and different physical and chemical properties. Same chemical formula but different structures and different chemical properties. So you've got a different version of something even though it might have the same chemical formula. Protein. Definition for protein: biological polymer made up of amino acids, catalyzes many cell reactions and provides structural materials for many parts of the body, like our muscles. An amino group, second to last definition I'm going to give you. An amino group is like an amino acid, but it's just the amine portion, which has a nitrogen and two hydrogens in it. Lastly, we have polymer. Our definition for polymer is large molecule made up of small repeating units linked by covalent bonds to form a long chain. Now, what I'm going to recommend to you is to watch this and to read through it maybe on your own with the glossary. So as Mr. Chain's looking these up and reading these to you, it might be beneficial to get these definitions in front of you so that you can read them and hear them for yourself. Now I want to try and apply those definitions that we just read through to the sentences that are here. The directions say use the following terms to complete the sentences below. Number 1, a blank will leave a greasy spot on a brown paper bag. Number 2, a runner might eat lots of blank before she runs a long race. Number 3, proteins are made up of smaller molecules called blank. 4, blank. All blank contain the element carbon. 5, a nitrogen atom joined by a covalent bond to two hydrogens is a blank. Number 6, a blank is a long chain of many small molecules. 7, an important building block of muscles and tendons is blank. 8, a blank has the formula COOH. Number 9, an alcohol is formed when a blank replaces a hydrogen atom in a hydrocarbon. Number 10, compounds that have the same formula but different structures are blank. 11, all of the bonds in a blank hydrocarbon are single bonds. Number 12, hydrocarbons with double or triple bonds are blank. Now I went through it blank that time just so you could see any of those quick definitions that you've read through once come to mind as the answers for these. For example, for me, number 1, a blank will leave a greasy spot on a brown paper bag. If you've ever eaten greasy food, you know that it contains some type of fat or lipid. A lipid will leave a greasy spot on a brown paper bag. Some of the fast food that we eat, like the French fries and burgers, those type of things are going to have lipids or fats in them that leave that greasy spot behind. Number 2, a runner might eat lots of carbohydrates before she runs a long race, because it said that carbohydrates have carbon, hydrogen, and oxygen, and they contain a ton of energy, including some of the sugars that we eat. Number 3, proteins are made of smaller molecules called amino acids. Amino acids are the building blocks of proteins. Number 4, all blank contain the element carbon. Organic compound was the dead giveaway there. Something is organic, it has carbon, that means it's a lot of times a living material. Number 5, a nitrogen atom joined by a covalent bond of two hydrogen atoms. We describe that as an amino group, not an amino acid. An amino group has a nitrogen and hydrogen attached to it, two hydrogens in fact. Number 6, a blank is a long chain of many small molecules. Well, the word poly means multiple, so polymer is multiple molecules, where a monomer would be one molecule itself. So polymer. Polymer is a long chain of many small molecules for number 6. 7, an important building block of muscles and tendons is protein. 8, a blank has the formula COOH. Anytime we're talking about the combination of elements in the molecule, we're looking at these different types of groups. So we already got amino group. This one has a carbon, oxygen, and hydrogen. That's describing a carboxyl group. COOH means a carboxyl group, right here, number 8. Number 9, an alcohol is formed when a blank replaces a hydrogen atom in a hydrocarbon. That would be a hydroxyl group, hydroxyl standing for hydrogen and oxygen. An alcohol, OL, is formed when it has OH replacing a hydrogen in a hydrocarbon. So there's an OH attached to that new molecule. Number 10, compounds that have the same formula but different structures are called isomers. Different structure, same formula are called isomers. Number 11, all of the bonds in a blank hydrocarbon are single bonds. That would be saturated. Saturated for single bonds, saturated for single bonds. That's how I remember that. Number 12, hydrocarbons with double or triple bonds are called unsaturated. That should be all of the answers for our key terms. Hopefully reviewing those definitions by reading through them the first time and then trying to apply them starts to cement them in your brain. Now that you've got a good understanding of what those terms are, when you come across them in your reading, you'll even have more understanding and be able to connect those contexts to what we're studying. God's blessings.